Hello students, in this video we are going to discuss the chemical reaction of carboxylic acids involving the cleavage of a COH bond. So in this we need to discuss the following reactions, that is formation of anhydride, esterification. Third is the reaction with PCl3, PCl5 and SOCl2 and the reaction with ammonia. So let us discuss these reactions in detail one by one. First is the formation of anhydride. Anhydride can be formed from carboxylic acids. That is, carboxylic acid on heating with mineral acids such as H2SO4 or with P2O5 give a corresponding anhydride. That one example it is taken here, that is ethanoic acid. When the two molecules of ethanoic acid that is heated with the mineral acid H2SO4, that's why it is written as H positive and the triangle sign is representing the heating, or with the help of P2O5. So what it gives rise to? It gives rise to an anhydride that is called as ethanoic anhydride. Now I will tell you how to make this product. You have to write the ethanoic acid in this way, how it is written here, and just remove one water from here, that is here from H and from here OH. Remove water from here. So what is remaining here? One oxygen is remaining. That is from here one H and one OH is to be removed. That is the water is removed. So here one H, one O is remaining here. That O is here. So we can see that it results in the formation of an anhydride. That is, this product is called as ethanoic anhydride. If you remember, we have already learned the general formula of anhydride, that is R C double bond O, O C double bond O R. So this is here the anhydride where R is the CH3 here. So you can make any anhydride by taking any two carboxylic acids, and you have to write in this way how it is shown here. So you can make very easily the carboxylic anhydride, you can easily make by doing in this way. Next is the important reaction, that is esterification. Esterification, the word comes from the preparation of ester. The preparation of ester is called as esterification. The general representation of ester is RCOOR-, where the two alkyl groups are there and there is one carbonyl group here, R, C double bond O and OR-. Here the carbonyl group is attached to OR-, that is an alkoxy group. Now here esterification, that is a process of formation of ester takes place when the carboxylic acid and alcohol combines in the presence of a mineral acid H plus. It gives rise to ester plus water. That is, the carboxylic acids are esterified with alcohol in the presence of H plus, that is a mineral acid such as concentrated H2SO4 or HCl gas, so which act as a catalyst here. So that result in the formation of a ester, that is this. Now how you will be making this product, as we have already discussed this reaction in the during the properties of alcohol, we have already discussed this equation. So how you will be making this product here? Better you write this in this way, that is R C double bond OOH. This is acid, and alcohol we are writing as, just write it in the reverse order. So HOR-. Now from here you have to remove water, that is you have to do a cleavage of this bond, that is the bond here, this cleavage is taking place, and here one H. So what is formed here? Water is formed in this way, that is OH from acid and H from the alcohol. So it results in the formation of water ester. Just combine these two parts, you will get the ester. So this is the reaction called as esterification, and it is one of the important laboratory test to identify the functional group, that is acidic functional group. We can identify by this test, that is called as ester test. And we can also identify the presence of alcoholic group by this test, that is ester test. So we can able to distinguish the acid with any other group, functional group, by this test, that is ester test. So this is the test which we are doing in the laboratory. So the fruity smell which that shows the presence of ester, it shows the presence of carboxylic acid group. So next we'll be going to discuss the reaction with PCl3, PCl5 and SOCl2. This reaction, that is the reaction of acid with PCl5, give rise to RCOCl. Here what we need to do here in this reaction, so better I will expand this one of the reaction, that is RC double bond OH, that is acid, when it is treated with PCl5, PCl3 or SOCl2. In all these cases we'll be getting the same product. And how to make that product, that is you have to remove OH from here. Remove OH from here. So what is remaining here? That is RC double bond O is remaining, and you need to, that is I am writing here what is remaining here, RC double bond O is remaining, OH is removed, and what you have to add in the place of OH, that is Cl. We have to add Cl in the place of OH. That is important. So when you are making this type of equation reaction, if you are doing this one, so what you need to do when there is an acid, and if it is PCl5, PCl3 or SOCl2, what you need to do, just remove the OH from the acid part and just keep a Cl in the place of the OH group. That's why you're getting the product RCOCl. That is what it is written, RCOCl. And in all these cases the main product is same, that is the acid chloride is formed, but the side product are different. This reaction we have already learnt in the alcohols. Same here also we are doing in because in alcohols the reaction is like this, ROH. So PCl3, PCl5, SOCl2. In all these what we are doing, just we are removing the OH and we are keeping Cl. That is we are getting the product RCl. So here also what we are doing here, we are removing the OH part and we are keeping one Cl in that place. So this is the reaction we have already discussed in the first chapter of organic, that is the preparation of halides. So here also in the acid also we are doing the same thing, just remove the OH and keep the Cl. So whenever you are learning this equation, learn the equation for alcohol and acid together, so that will be more easy to learn. So what you need to remember here, so in the case of alcohols and carboxylic acid, then there is a reaction with PCl5, PCl3 or SOCl2. So what you need to remember, the hint here, just remove the OH and add Cl in the place of OH. So here also without expanding this, you can write the product, remove the OH and keep the Cl. Here also remove the OH, keep the Cl, like this we can do. So this reaction is very easy and important also. So better to learn this in this way. Next is the reaction with ammonia. Carboxylic acid react with ammonia to give ammonium salt, which on further heating at high temperature give amides. So here the reaction is with ammonia of acid, as we know that acid and base, there is a formation of salt. Acid plus base give rise to salt. Here ammonia is a base. We know that ammonia is a base, and the acid, that is carboxylic acid. So there is an acid base reaction here. That means there is a donation of proton. So one H positive is donated from this acid to the base. So ammonia will accept it to the H plus and form NH4 positive. And what it is remain here, that is CH3COO negative. So CH3COO negative plus what we have, the ammonium ion NH4. So together what we can call it as a ammonium salt. We can call it as a ammonium salt, that is CH3COO NH4 positive. Now which is further heated. When it is further heated, so what happen? It results in the formation of amide. So there is a formation of amide here, that is by removal of water. That is, one water is removed from here, that is clear from this equation. 2 hydrogen from here and 1 oxygen from here, it is removed. So that is water is removed. So now the product which is formed here, that is called as amide. And this amide is particularly named as acetamide. So when we take a benzoic acid, in the same way we can do benzoic acid with ammonia, give rise to ammonium benzoate. That is a salt formation here is taking place, that is ammonium salt is formed here. So this is called as ammonium benzoate. That is when further heated, there is a removal of water that results in the formation of a amide, and this amide is called as benzenamide. So here the reaction of carboxylic acid with ammonia, first it gives rise to ammonium salt, then which is further heated to give rise to amide. So it is one of the important reaction of formation of amide from acid. From acid we can prepare amide in this way. So when we take another example of the acid here, when we take this type of acid in which the two acidic group are adjacent to each other on the benzene ring, that is called as phthalic acid. So phthalic acid plus ammonia, so same way you have to do, just keep NH4 positive here, that is a result in the formation of ammonium phthalate. Now here remove the water from these two. So what it formed here, that is formed as phthalimide. Now this is called as phthalimide, and when ammonia is removed from here, how it is removed? That is in the strong heating ammonia get removed. That is NH3 from here, sorry NH2 from here and 1 H from here is removed. That is ammonia is removed. So that result in the formation of here a linkage between these two carbon by NH. So here there is an formation of a phthalimide. This is called as phthalimide. So it is also one of the important reaction, that is the reaction of phthalic acid with ammonia. So in this video we have discussed some of the reactions involving the cleavage of COH bond. This cleavage we have discussed. So these are the very important reaction which will be useful in the conversions also. So this is all about this video. Have a nice day.